In this video, we're going over ugly numbers. So an ugly number is a positive integer whose prime factor are limited to 2, 3, and 5. So given integer n, return true if n is an ugly number. In our first example, we're given this number 6, and we return true because 6, the prime factors of 6 is only 2 and 3. And we want our prime factors to be limited to 2, 3, and 5. So we return true. Let's go over the dot process. So an ugly number only has prime factors limited to 2, 3, and 5. If we are given a number n, we can continuously divide n by 5, 3, and 2 to check if it reaches the value of 1. So for example, we have the number 15. Now 15 is divisible by 5, so we can divide 15 by 5. So we get 15 divided by 5, and we have 3. Now 3 is divisible by 3, so we get 3 divided by 3, which will give us the value of 1. If we reach the value of 1, this means the number n has only prime factors limited to 2, 3, and 5. Now let's go over the pseudocode. So let's validate the input parameter. If n is less than or equal to 0, then it does not have prime factors limited to 2, 3, and 5. We can just return false. Now while n is divisible by 5, we're going to divide n by 5. Now while n is divisible by 3, we can divide n by 3. And then while n is divisible by 2, we can divide n by 2. They only return true if n is equal to 1. Else we'll return false. Now let's go over the time and space complexity. For the time complexity, we get O of log n, where n is the input value. This is because we divide n by 5, 3, or 2 each time. And our space complexity, we get O of 1. Let's go over the code. So we'll first validate the input parameter. If n is less than or equal to 0, it's not an ugly number, so we can return false. Then we have while n is divisible by 5, we're going to divide n by 5. And then while n is divisible by 3, we're going to divide n by 3. And then while n is divisible by 2, divide n by 2. They will only return true if n is equal to 1. Let me know if any questions in the comment section below.